Okay, welcome everyone. Thank you all for braving the weather to be here. It's great to see a great turnout. We have a great lineup of talks and a great panel as well. Uh, Sorry. Um, a little bit about myself. I'm Swati. I'm a senior manager of engineering here at LinkedIn. I've been here for about 5 years, and I support teams that build the distributed systems for configuration and metadata management, powering all of LinkedIn data infra. And outside of LinkedIn, I have a 13-year-old that I like to bake, go on hikes with, and do some art with. Our current obsession is Woobles. Anyone into Woobles? Yes? Okay, we have one person. Okay, and I'm thrilled to be co-hosting today's event with Radhika Rangarajan, who is the co-founder for Women in Big Data. Okay, with that, let's get started. A few housekeeping reminders. Please keep questions to the end of each section. We have a mic here at the middle. If you could all line up, that would be great. And we'll let you know if we have enough time for questions, but at the most, we might be able to take 1 to 3 questions max, but please feel free to hang out during the networking portion and ask more questions. Please put your phones on silent. And there's a signage outside for restrooms in the corridor to the left. Food and refreshments out to the on the side. We'll have a little bit more towards the end during the networking section. We have rock your profile, more opportunities to get your headshots and network with everyone who's attending here, roughly around 4:40. And be prepared for trivia questions. You have, if you get the answers right, you get swag. Okay. A quick note on the agenda. As you can see, we have a very packed schedule. we have Keynote, we have panel talks, we have lightning talks. I'm really excited to get started on it.
Hi, everyone. How's everyone doing? Awesome. Yeah, make some more noise. Thank you all for being here and incredibly grateful for LinkedIn for throwing this amazing event. This is our 3rd or 4th year we've been doing this, and we should do more often. I'm Radhika Rangarajan. I'm one of the co-founders of Women in Big Data. I've worked at the intersection of cloud and AI and data for 25 years. Since Swati said something interesting, I don't know if it's interesting or not, but last evening I was at a junior college workshop for 4 hours because I have 2 teenagers, and it kind of made it all so real for me. But anyway, maybe we can just.
Oh, yes.
So I want to say a little bit about Women in Big Data. It's started out as a passion project 10 years ago. This is our 10th year. And we started as a conversation in a conference room at Intel. Literally 3 people. Then we invited a bunch of our friends in the Bay Area, 15, and it was a Bay Area meetup. And actually, this event is sponsored by the Bay Area meetup team for Women in Big Data as well. And well, 10 years went by a little too fast. We are now 20,000, over 20,000 worldwide, 50 plus chapters, and it's all volunteer driven. Just in this room, I've already spotted about 10 Women in Big Data volunteers. So it's completely done by a whole lot of volunteers worldwide. And I think last year we clocked in 10,000 volunteer hours. So it's an amazing organization that is actually focused on bringing more diversity in data and AI fields. And hopefully you will all actually be able to participate, be a community member, volunteer. And it's open to all genders. Yes, it's called Women in Big Data, but come on. Let's be inclusive, right? So this is what we do. We run events, we run training programs, we run hackathons, we run workshops, we run technical certification. Like I said, just to put things in perspective, through our programs, our training programs, we have over 7,000 learners on our Data Camp Donates platform. That just tells you how much appetite is there for people to actually come in and upskill themselves. So there's a lot of interesting work that's been going on. And this is our 10th year, a milestone year. And we are going to take our story to the road. And we're going to actually hold 10 workshops, 10 roadshows around all our chapters, all the key hubs. So watch out, tune in for that. And there's more to come. I think we want to actually do a trivia, right?
Yes. A quick note about the trivia. This is a multiple choice question. So what we ask for you, this is very low tech. We ask that you please raise your hand, and we'll pick someone at random. And if you guess right, please come and grab a swag bag over there. All right. With that, let's go with the first one. It's too low still. No, I can hear myself really loudly. Can you hear me now? If I speak this loud?
Oh, okay. Really? Hello?
There's an echo.
There's an echo.
I'm good. Okay, I just need to speak louder. Okay. Okay, I'm going to reiterate. Please raise your hand. We'll pick someone after asking the question, and if your answer is right, we will ask you to grab a swag bag. Okay.
Now, this is kind of a very important one because the swag bag has something special from Women in Big Data. So get this right.
Okay,
We just recently launched a chapter. Where did we launch? Just one hand. Come on.
Fine. Yeah.
All right. Okay. Yes. She raised.
Yeah. Go ahead.
Oh yes.
Yes. The right answer was
right
Poland.
Answer. Yes. On International Women's Day, we launched our Poland chapter. So
awesome.
Awesome.
Cool. Yeah. Give it up, and yeah, please feel free to grab a swag bag from over there. Is this better? Oh, okay. Okay. Okay, on to the next one. What is the approximate size of LinkedIn's economic graph? Is it A, 250 billion edges, 1 billion nodes, 250 billion edges, 10 billion nodes? Or C, 450 billion edges, 1 billion nodes? Or D, 450 billion edges and 10 billion nodes? Any guesses? Don't be afraid. Yes, over there. Sorry? D, you're not quite. No, it's not B either. Okay, Alicia, over there. Not B. It's not B. Yes, it's C. Okay, by default, yes. We are actually nearly 460 billion edges, I believe, and 1.1 billion nodes. So it's approximate as of January this year. All right. So moving on. I would like to introduce our fearless leader and sponsor, Kapil, to speak a few words and introduce our keynote speaker.
Hey, thanks, Swati. Hey, great to see everyone here. My name is Kapil Surlakar. I'm a VP of Engineering here at LinkedIn, responsible for all of our AI infrastructure. And certainly, as you see, scale is something that we deal with and has been increasing for a number of years constantly that I've been here, right? Very, very excited to be hosting this event today with Women in Big Data. I've had the pleasure and the privilege of supporting the organization for a number of years now as an ally. And, I think before the pandemic, we had a number of such events. And unfortunately, the pandemic put a stop to that for a while. So I'm really excited to get back to it. And with such an amazing topic, right? So we are here today, and the topic for today's event is responsible AI at scale. And we couldn't have a more relevant topic, right? The field of AI has been making such rapid advances recently, like literally the state of the art changes on a day-to-day basis. And while those advances create incredible opportunities, they also place significant responsibilities on us, right? How we design, deploy, and govern AI is going to be very, very critical for our future. And not just for business and the products that we build, but also for the society at large. And certainly that's very true at LinkedIn, where as a members first company and with the vision of providing economic opportunity for every member of the global workforce, responsible AI is something that we very, very deeply think about, right? And I'm really looking forward to the amazing lineup today where we have domain experts and practitioners in the field, both from LinkedIn and domain experts in the industry, come and share more about what's going on in this space. So looking forward to this amazing lineup. With that, I'd like to welcome our keynote speaker for today, Hema Raghavan. Hema is the co-founder and VP of engineering at Kumo AI, where she leads the AI technology development to enhance the machine learning models, right? And before that, she was a senior director of engineering here at LinkedIn, working on AI-driven growth products like People You May Know. And I had the pleasure of working very closely with her. So great to see you back here. And prior to LinkedIn, she worked on research at IBM and Yahoo, and she got a PhD in computer science from University of Massachusetts at Amherst, and she has a degree in computer engineering from University of Mumbai. So over to you, Hema. Thank you.
Thank you, Kapil, for the warm welcome, and it's good to see familiar faces here. This is a great forum, and I think it's my third time in this forum in different capacities and iterations of this forum. This time as a co-founder, head of engineering, and it's a startup. I'm also the chief privacy officer, chief security officer, many hats in one. And this is the journey, not necessarily of the Kumo product as such, in terms of it's not a product pitch, but I want to tell you all the questions or problems that we encountered that we had to solve in building a machine learning platform. But I will talk a little bit about the product so you know what we're building for, and then I'll talk to you about questions that came up and how we went about solving them. So we started Kumo in 2021. When I left, that's when I left LinkedIn. And I have two other co-founders, Yuri Leskovic, who's a professor at Stanford and was chief scientist at Pinterest, and Vanya Josifovsky, who was at Airbnb as CTO. And we saw patterns in the AI machine learning landscape in each of our companies. And when we noodled on it, we thought, here's an idea of how we can bring the deep learning revolution to data in relational format. Okay, so that was the genesis of Kumo. We also brought the team from PyTorch Geometric, which was an open source library, two scrappy students in University of Dortmund who put out a library as part of their PhD thesis, which by the end of their PhD got 14,000 GitHub stars. And we were like, you know what? Would you want to join us in forming this company? Because the genesis is that graphs can actually map to relational data. So that was the founding team. And we've been an active supporter of open source. And that actually drives some of our strategy. So we put out PyTorch Frame, RelBench, a bunch of open source data sets and benchmarks. Kumo, of course, has a paid product as well, where we do, think about scalability and an enterprise version, but we do support open source. So our mission is predictive tasks on any relational data. And really, it's predictive is the keyword. So differentiating from the Gen AI landscape, where you're asking questions of world knowledge, you're asking pointed questions like, what product will a user purchase next, right? That's your recommender system problem. Is a user going to churn? What notifications will get opened? How much volume of a product will get sold? These are all predictive AI problems, and LinkedIn works, I think there may be thousands of models within LinkedIn on these kind of predictive AI problems. But the classic way to solve them used to be XGBoost. You took all those tables, you joined them. We gave Kapil's team, when Kapil was running Hadoop, a grief because we would just be joining table after table after table. And I have teams I have team members here, and we worked jointly on optimizing those joins. But that was the way we did ML in a CPU era. So when we formed Kumo, we said, how do we just skip past all that manual labor of feature engineering and bring that same revolution that's happening for text, for LLMs, into this tabular relational data. So Kumo coined this term, and now it's generally accepted. It's called relational deep learning. There's a ton of papers. We're not the only authors of relational data deep learning. There's NeurEPS workshops and KDD workshops on the same. You should go look it up. The original innovation that led to us thinking of relational and graph as two ways of looking at a problem was the PinSage paper or the GraphSage paper, which brought graph neural networks or graph attention mechanisms to the front. Now, when we started Kumo, we said, graphs are powerful. We saw that at LinkedIn. Yuri saw that at Pinterest. But even within LinkedIn, not everyone thought of their problem formulations as graph. Everyone thinks SQL. And then we started playing around and we said, hey, SQL and graph can actually map into one unified framework. And over time, under the hood, Kumo is all about graph neural networks. I'm excited to hear the LIGNN talk later. But we've also evolved in terms of the architecture. So we're not just a platform that makes PinSage available. We have many customers in many domains. I'll talk about that in a moment. But our latest architecture is out in ICLR. And we also allow you to combine the dense self-attention that you get from LLMs. So we don't claim to be an LLM platform. You can actually call OpenAI or Anthropic or whatever you want from Kumo. You can bring in embeddings. Embeddings turn into node features, and then the graph really takes over the sparse cross-attention. But again, nobody thinks in terms of graphs. So in order to make that really easy, from a product perspective, we said, you know what? We're just going to make it really easy for you to register your relational data, and we're going to give you a language that looks a lot like SQL. So we have a language called predictive SQL, and it's beautiful. If you like programming languages, we actually discovered that all ML problems can be reduced to either a node prediction problem or a link prediction problem on a graph. And therefore, we were able to actually define a language that's a unified language that lets you specify anything from forecasting to recommender systems to lifetime value to churn and so on. And then we let the GNN learn the features. So here's a little bit about the richness of the language. I'm going to open up the product and you can actually see it. We have a ton of customers. Some of these customers are willing to share more publicly that they work with Kumo, but you can see the range. It goes from consumer, and because I worked in growth and so did my co-founders, we actually started in growth use cases in consumer. But since then, we've actually moved on to work with B2B and now even fintech. So we have a set of fintech customers. We also have healthcare. So with Kumo, we have two UIs, and you can or two ways to access the product. There's a web UI and an SDK. And like any SaaS product, when you come in, you interface with Kumo through a connector because we're all about relational data, right? And you can specify your data warehouse of choice. It can just be pure S3, but it can also be, Snowflake. It can be Databricks. It can be any one of these other things. And then I'm not going to, do a full demo, but once you have a connector, and here I'll be using the H&M data set. H&M is a clothing store. So, and you can do, product recommendations, churn, lifetime value, whatever you want on it. Once you bring your data set and you have, you next start ingesting tables. Now let's say I want to ingest a table. I had a connector, H&M, and let's say I want to bring in the customers table. So now Kumo actually makes it really easy. You don't have to specify types, but we'll start inferring column types based on data. And here's the first place where customers care for control. For example, they may say age is PII. I don't want Kumo to ingest age, right? People bring in, especially in an ecosystem like Snowflake, they'll bring in data through views. So, you can write some SQL, you can actually hash PII and bring in data as views. So we had to start giving in all of those capabilities. Now, to make life easy and not have to do joins, the next part about Kumo is this whole graph bit. But you can just, Kumo can look at the metadata, say, these are 3 tables. You don't have to worry about writing those massive left join, right join, optimizing those joins, and so on. But this is where the graph comes in. The next bit is writing predictions. And let's take this H&M graph. And Kumo's value prop is, let's say I say predict, and I want to say, what's the count of transactions star in the next 90 days for each customer. Customer ID, and I can give a where clause. So for those of you who do machine learning, you spend inordinate time pre-processing your training data. So, you say, I want to build a churn model which predicts over the next 90 days. And you say, but do I know if the last 60 days of data is useful, or is it the last 30 or the last 200? Each of those is, again, pre-processing logic, whereas Kumo just says, hey, you can just specify this as -60, 0 days. And you can play around. You can write 10 predictive queries and you can hit, start training, right? And okay, I have a syntax error, but I think that's oh, I think I need actually I need an equal to 0 here. Yeah, and this was the second thing. So when we started Kumo, we said we'll just have a predictive query language, and Kumo's a black box. But the next thing that people wanted was control, because they said, look, I really need to understand what the model does. So we started, just like in database language, there's query planners, we started exposing the model planner. And it not only tells you how the GNN is training, but it starts telling you the kind of metrics that we'd like to report. So we just started with AUROC, precision recall curves, and so on. But then our recommender system customers started saying, hey, you know what? I want a metric around diversity. I want a metric around popularity bias, and so on and so forth. So if you go into our documentation, we have a whole list of metrics. So we had started to give controls to users to be able to play around with how they wanted to, shape their product, right? Coming back into the presentation, the next thing about Kumo is actually when you hit training here, we have a predictive query, no issue, it says looks good, I hit start training. What happens is Kumo takes the data into a VPC, right? And it's a per one VPC per enterprise. So, enterprises care that there's no commingling of data. They care about network boundaries, and they care about whether Kumo stores the data. So the only thing we do is actually ingest the data, build the graph, and we cache the graph because that gives you performance, but we give you TTL to your cache. And most people specify it at the standard 30 days so that you're GDPR compliant. So we started having, as we started building the product, we had to start giving these controls. The rest of Kumo is mostly compute engine, Kubernetes clusters that spin up and spin down when training happens. Then as we started going into more fintech and healthcare, we started discovering that they didn't even want egress, which means they wanted no data going over the network. So then we started building data warehouse native deployments of Kumo. So you can go to the Snowflake marketplace, for example, you can click on install Kumo, and Kumo completely deploys inside your Snowflake warehouse. So, and that's something security teams love. Even within our SaaS product, we had to think about encryption, access, multi-tenancy, auditability. Like, can I give access to my entire logs to a security team in case of, a breach? Privacy and compliance, that's, GDPR, CCPA, all of that came to be. Then there was training data, the ability to give the user control to anonymize training data, right? And we have an interesting story here because we were working with a healthcare customer, and we anonymized all fields that you would think were typically anonymizable. Can you guess why timestamp would have been a PHI? Okay, so the problem we were predicting was patient readmission risk prediction. And celebrities' admission dates are on the news. So you can actually go in. So even if you anonymize everything, but then if you time shift the date, the training data was all COVID. So we lost seasonality when we, time shifted. So we suddenly didn't have flu season. So it was a big mess. We still don't know how to solve that problem, actually. So I'm saying in spite of us giving controls, we got exposed to new problems that I had not thought of in my LinkedIn career. The granular controls I, talked about. And I was asked to give a trivia quiz. So I'm going to ask one more on controls, which is what percentage of Americans can be identified using zip code, birth, and gender? Yeah. Okay, one said 73. Yeah. Okay. And anyone else want to take a guess? Okay. Yeah. It's actually 87. There's an MIT paper on this. So it's very easy to de-identify. Just very quickly, a few screenshots, but I had to start putting documentation because even for our recommendation system customers, we had to start thinking of how do you handle new users? New users can't have a bad experience, or you have new items on a marketplace. How do you handle that? So so there's a lot of knobs and controls we started giving in the platform. We started giving, controls around metrics you optimize for. So we started with the standard, but then we started adding metrics like personalization, diversity, and all of that, because customers would say, you know what, I'm willing to drop a little precision recall for better diversity, better, personalization. And then we had customers who had different ideas of quality versus spam. So for example, iFood uses Kumo for tobacco detection. So does a product contain tobacco or not? And that may be a complete filter, in a certain market or in a certain demographic. But you might want to downweight those examples based on the product. So we started giving controls on how do you weight training examples. And the last was, when you go to fintech and healthcare, people actually want to understand what goes into the model. And this was, again, a third axis on which we had to innovate, which was usually we dismiss deep learning models as not being explainable, but we actually had to go in and we build out an entire explainability part of the product where you can actually go in, you can actually see what features are important for your model. Evaluation, explanation. But you can actually explore the graph on a per entity basis. You can go down to, what's the neighborhood that was used. You can go down at the aggregate level. And actually people like that because now, because it's tabular machine learning, You can go down and say which table, which column was most important for that problem. And in fact, we've found so many, help customers find so many data quality issues because they'll go and say, hey, this model doesn't look intuitive. And we'll realize that somebody was ETLing and overriding columns with the wrong values. So that actually brings me more or less to the end of my talk. And I want to say, building a SaaS company, took us through a journey of understanding what responsible AI means. Responsible AI meant one thing to me when I was here at LinkedIn, but now I've kind of absorbed what responsible AI means, which for all of my customers. It includes security, it includes encryption, it includes bias, it includes privacy. So there's so many axes to this. And I mean, as a business owner, they're not going to buy my product if they don't trust me. So I think that's been, a huge part of that learning. I do want to put one thing out there, which is very different as building a company. I do find open source as a huge angle in terms of how talent and hiring talent. I think that was another learning in founding a company. You can just find good engineers anywhere in the world if they're pushing good code to an open source repository. So Kumo is actually global with people in UK, Germany, Austin, and the Bay Area. So that opened my eyes in terms of even talent and talent sourcing. And there are lots of new tools that made it really, enabled us to hire global talent wherever they are, wherever they needed to be for, personal reasons. Anyway, that's it. I think we can take questions. I'm at time, right? So we'll take questions maybe at the end or during the networking session.
Yeah, during the networking, perfect. Or we would have time after the panel. Yeah.
Thank you.
Thank you. Thank you, Hema. That was a fascinating talk. I did not realize you're discovering new kinds of data that are PII. Great to hear that. Okay. And now on to our panel discussion, where our panel will be discussing about building the future of responsible AI. Hema, don't go too far. You're going to come back to the stage. And I'm going to introduce the rest of the panelists. We have Joaquin, who is the head of preparedness at OpenAI, focusing on frontier AI risks and governance. He previously led responsible AI efforts at Facebook. He was a technical fellow at LinkedIn. And until recently, he also served in multiple advisory boards, including the Spanish government's advisory board on AI. He has a PhD from Technical University of Denmark. He's worked at Microsoft Research, delivered guest lectures at Cambridge University, and he was a postdoc at Max Planck Institute for Biological Cybernetics in Germany. Outside of all that, Joaquin somehow manages to find time to be an avid trail runner, triathlete, paella cook, and an amateur guitar player and folk singer. Please welcome Joaquin. Right. And next we have Grace Tang. She's a principal software engineer here at LinkedIn, part of the Trust organization, working to keep the LinkedIn members safe. With over a decade of experience, she has tackled a variety of issues, including fake accounts, fraudulent jobs, content moderation, and later she set safety standards for LinkedIn's first generative AI launch. In her free time, she enjoys building Legos with her 3-year-old son. Oh, there she is. Grace. Welcome, Grace. And Sakshi, you can all start piling up onto the stage. And last but not least, we have Sakshi, who's going to be the moderator of the panel. She's the director of engineering at LinkedIn, spearheading the responsible AI and governance team. She has a background in physics from IIT Bombay and advanced studies in ML and anti-abuse at UC Berkeley. She focuses on AI safety, fairness and transparency in recommendation and classification systems, and brings a unique blend of technical expertise and ethical vision. Previously, she also spent 6 years building ML systems to combat fraud and abuse, driving ethical AI solutions at LinkedIn. Take it away, Sakshi.
All right. Hello, everyone. Hopefully, everyone's excited about this panel. A fun side tidbit is all of the folks here are folks I've worked with who have mentored me on multiple occasions, have been my buddies in good and bad times. So I couldn't be luckier to be hosting this panel with friends and mentors. So, with that, I'll kick us off with a slightly interesting question. Okay. So before we get into the responsible AI, with AI just changing shape and scene so much, I would like each of you to imagine yourself in 2035. And AI, I actually can't even imagine. Like it's so far away. I don't know what's going to happen. But in 2035, imagine any setting that you have. Like this could be a workplace, this could be social interaction with your friends, this could be at home reading time, and paint us a picture of in this new AI heavy world, what would that look like for us? And maybe Joaquin, I'll start with you.
I was trying to pass the microphone. Hi everyone, it's really great to be back. I'm gonna take the optimistic view. I imagine a world where it's hard for me to distinguish an omnipresent AI assistant that I have from my own consciousness. This seems pretty crazy, but I remember years ago, one of the things that I would always find frustrating is that I'd come up with things that I wanted to look up on the internet, or maybe like thoughts or things like that, at a moment where I didn't have a pen and paper. And it'd be pretty awesome to have a way to have, like an assistant with infinite memory, full trust and all these things. The part that feels eerie or scary is that my guess is that at some point it would be almost an extension of my own consciousness, and how we navigate that is going to be really interesting, I guess, right? But I think done well, it can be like an amazing augmentation of my own capabilities. And also, as I grow older, I realize my memory actually deteriorates. So we better get working on this quick.
Awesome. I think that done well is what we need to expand more.
I can think of two scenarios. So I have a 9-year-old and a 12-year-old. So 10 years later, I'm going to be an empty nester, right? So they're going to be in college. So I have more time to travel. I have more time to for fitness. Those would be two goals, right? So I'm thinking from a travel perspective, can we just make airports really easier? Like I shouldn't have to put my luggage on a scanning machine. Can I, just breeze through immigration? Can all of that happen, but in a privacy preserving way, right? Like can travel be easy? And from a fitness, I think it's already starting to get there. And that's like a fitness coach agent kind of thing, which kind of, my watch still reminds me, hey, you have 2,000 steps more to go at 5 p.m. It's a bright sunny day. Go out, right? But how do you have those nudges, and how does it all connect with all of the other data? Because I'm going to be 10 years older. How does it connect and nudge me towards even creative ways of exercise, right? I don't have to go to the gym when the weather outside is great. Can it tell me there's a hike that you can go? Your calendar looks free. So I can think of that.
Just to open up the whole range of responses, like what if it was an environment where I could be entirely free of AI? I mean, I like work with AI. My husband works with AI. I'm sure like when my kid is 10 years older, probably be tinkering with AI. So it's like, maybe is there any way to actually turn it off? And like a phone is easier to put away. I suppose if I put myself in a metal box, maybe it's like AI free. But it's a curious notion where like, just like when we all came back from RTO, or when RTO like kicked in, right? All that people interaction. And I wonder if that would be something I might crave when the AI becomes omnipresent.
Hey, quite a span. I get that, as you were saying, Grace, is like smoke-free zone, AI-free zone. Maybe that's what it may look like. And it may be just like plants in a room where you just go and breathe. So extended consciousness, personalized healthcare, and easy airline entry hopefully we don't have, like, hopefully airplanes are better by then and no AI zone. Okay. So this hopefully sets a stage of how wild our future can look like and why doing this well is so important. The goal of this question was to just imagine the different types of scenarios. Like imagine learning in a new way, imagine interacting with your friends in a new way, imagine healthcare in a new way. So with all that in mind, what are the things we need to really think about to do this right? Okay, so with that, my next question. So we have three leaders here with very different AI solutions. We heard from Hema. Kumo is a SaaS company. They're providing a platform with many knobs to do AI right for their customers. We have Joaquin from OpenAI, which provides a general purpose AI model and or an AI system where anyone can ask any question that they would like. And Grace from LinkedIn, who is building an AI product. So the kind of problems, the kind of principles that each of them have to think about are quite different. So I want to give us a sense of what that looks like, what responsible AI principles are closest to you from that setting. So I'll start with Grace on this.
So I'm going to have some bias here. So I've spent, it sounds terribly scary to say, a decade working in the trust space. And so I think one of the principles within responsible AI is upholding trust, making sure that AI is doing things responsible and not generating harm in our communities for users and for people. So that one is particularly close to home for me. And I do think that it has started to shift because when I started first working on some of the Gen AI products, it was like, wait, now it's like starting to generate content. Like, so should it be allowed to say anything it wants to say? And so very quickly we're realizing like we need to have standards around that. And do the standards, like I've worked in content moderation space, do the standards look the same as what we might moderate for regular content moderation, like UGC, user generated content? We realize, no, the bar might actually be higher if it's being, if these products are generating content on behalf of a company. So we realized that was an extension. Then we're like, wait, like users can input text here now, right? Like, so they have some control over this tool. And so then it also became of like, well, this is a tool, and when used right, that's all great. And when used wrong, that's really, really terrible. And so we also found ourselves looking more closely around like who is using it, because in the wrong hands, it really allows people to scale that abuse.
I think I spent the talking about what responsible AI meant at Kumo, but it's for me, it means because we're a platform and people use us to build AI driven products, right? Search recommendations, even for example, bad actor. Like I know Grace used to work on that. And now we have customers, we're doing the use of note diction problems, and their precision matters. So I've learning to absorb by just the span of use cases that I'm seeing on what responsible AI means. And we've been evolving the platform as we talk to trust and safety and security teams. In fact, one of the big our procurement process always starts with trust and safety team, I think. So I'm spending a lot of time talking to trust and safety teams these days.
Raise your hand if you heard J.D. Vance's speech at the Paris AI Action Summit. Okay, most people didn't. You should. It's this is not an endorsement or a non-endorsement. It's just a reflection of how the climate in which we build AI can change, and can change fast. A couple of years ago, when I first started paying attention to OpenAI and before I joined, I was struck by Sam Altman testifying in Congress and warning the world about the catastrophic risks of AI and how we should be extremely careful that this technology could get out of our control and destroy humanity. J.D. Vance, a couple of months ago, said, I'm not here to talk about AI safety, I'm here to talk about AI opportunity. And so the climate changed. So my principle, zooming out, for how to approach responsible AI is one of taking a practical approach. And to me, a practical approach has to mean an approach that is well calibrated. One of the things that I have a couple of pet peeves, and one of them is intellectual laziness. And I feel like the extremes are intellectual laziness. I feel like the approach that focuses only on the catastrophic risks and almost leads to paralysis is intellectual laziness. And I think that the approach that is cavalier and says, just ship it and we figure out what happens is intellectual laziness. The real work happens in the middle, right? And you need to do three things at least, probably many more. But one of them is you need to embrace uncertainty and you need to take an iterative approach. You need to understand that, look, we don't know what's going to happen, right? I have close friends who work at Waymo. I've followed quite closely the very, very tedious multi-year, just work the problem in detail, right? Iteratively. It works that way, right? I have notes because you see I need that assistant that we haven't built yet for the memory. The other one is a multi-layer approach is very practical, right? Like on the one hand, you have to shape model behavior, make sure that models know when to refuse, but that doesn't work very well. So then, like Grace was saying, you then have to model user behavior, right, and put a layer there as well. For those of you that work on or have built a KYC, know your customer systems, you have to do that as well, right? And then the final thing is, and this is going to become increasingly important, is keep the human in the loop, right? Like the iterative approach only works if you actually have visibility monitoring. And I think in some of your questions later, I'll talk more about other things and how you can use AI to do all of this. But I'll stop here. Yeah, a calibrated and practical approach and avoid the intellectual laziness of the extremes.
Thank you. That hopefully gives a diverse range of ways we can approach. And also one thing to note is it really, doing AI responsibly is really a function of which space, which service, which product you're in. The definition itself changes for everyone. And therefore, it starts with what is it that we care about? What is it that impacts our customers and members and users, and start from there and go backwards. So I'll actually pose this question, Joaquin, back to you again. In a scenario, so today, like I don't remember a time when we were launching new products in the Valley or globally at a weekly cadence, right? Like the pace at which we are moving is something like I have not seen before. I think this is really new for this industry. At such a time, how do we think about the challenges in building AI safely, consistently? Like how do we think about the challenges, if you can add flavor?
Yeah, to illustrate what you just said, at OpenAI we have this thing called the preparedness framework that we published a year and a half ago. It talks about the catastrophic risks and how to measure them. It assumes still a world where pre-training is everything and you spend months doing it and you ship a couple of models a year maybe. We no longer live in that world, for sure. Sorry, what is the question? Apologies.
The challenges of of safety with speed.
One of the things that keeps me up at night right now is to avoid a race to the bottom. So when you think about a responsible AI framework, it's natural to think about incremental risk and to think, okay, if I ship this thing, what is the best, relative to, like, let's say DeepSeek R1, right, which is out there, it's open source, and does it have the same safeguards as the models we did ship? And we spent like months, working on them, and then they ship something, or like Grok, right? Like, is XAI going to have the same standard of safety than we are? And how does that change the conversation with the execs internally, right? And with our chief product officer, who's like, dude, we need to ship the product. Like Perplexity is eating our lunch, right? Like they're shipping deep research before we do. What's the deal? So avoiding the race to the bottom is the thing that really worries me, and I think it's very hard. And again, like you have to battle this right in the middle, where like on the one hand, you need to educate the world about your findings. This is why we publish system cards, and I have these very lovely full body contact sports, fights with legal and others on like, hey, what we really need to be talking about these things, right? Because look, we're not going to stop other labs from shipping stuff that has fewer safeguards, but at least we can educate people on what the risks might be. And I think the second one of which I hope to see all of us work more on, is contribute to an ecosystem of safety tools and solutions, right? It's almost like create vaccines. If you know that there's going to be like AI-made pandemics coming, and they're coming, we can talk about that later, because models are getting really good at helping bad actors with biology. How can we also help the people creating defenses, at an equal rate? And then finally, hopefully, if we have like third-party offerings, right? And at OpenAI, of course, we do. For people who don't want to have headaches about compliance, like, hey, I want to use a platform, or we want to use Kumo. I want to use a platform that, at least where I know by design, I'm going to be compliant and even beyond compliant, right? Like I know this is a caring platform. Then let the customer sort of vote with their feet as well.
Kumo.
I'll build off of that, right? Because I always think in terms of sub-processors. That's one thing, even from a Kumo perspective, right? Like people want to know what sub-processors, like, they call Kumo, what APIs am I calling in turn? Am I calling OpenAI? Is OpenAI HIPAA compliant? If it's if the customer's HIPAA compliant, am I transparent around that? And in a young startup, it's, for me, as in all these different hats, it's pretty easy to maintain that culture where, the team is very security aware, very privacy aware, and, they'll just holler on Slack, is this compliant? On, like, our Hash General is just thriving with so many threads, and it's a small company. When I talk to CIOs of larger companies, we had a phase where, and to your point of, there's just so many startups out there and so many products that people didn't want to be left out. You gave every developer a budget, and if it's token-based pricing, it became easy to experiment. But then when I talk to a lot of CIOs, they're most concerned about, now I don't know, like, what API is being called with what data. And things are out of control, and people are reeling that back in. So I think that boundary, like, I think it's been easy, like, for me as an organization leader, how do I keep that? It will eventually become process. Now it's part of culture, but it'll have to be process. And how do we bring that to scale? But then when I talk to other CIOs in the Valley, that's their biggest concern.
Thank you, Hema. Grace, talking about scale and big company and CIO concerns, tell us your challenges that you've seen in this.
I think at a moment in time, I think there's probably hundreds of engineers that are making changes. Okay. All right. So I think at any given moment in time, there's like hundreds of engineers at the company. They're making prompt changes. Some of those are going to go to production. Maybe it's a 1%, 0.5% ramp. Like, does that mean we need to do a full-blown revetting? Have they changed 2 words in their prompt? Have they changed a hyperparameter? So there's definitely this tension, even at like at a AI product building company, to basically enforce responsible AI, but then make sure you're not always viewed as like the launch blocker, like the anti-growth, anti-engagement like type of team. So that tension always exists. What I found to be helpful was really, automation is the first thing that comes to mind, but that's also not always the solution. Like if you're pumping lots of tests through a system, that can cost a lot because you're triggering the whole ecosystem. Can you be more, maybe manual red teaming is more productive because you can more selectively test for really the high concern areas. And so what I want to say around this is that, like, it's really creating a suite of mitigations. Some of these mitigations could be around process, where you're educating people so they just build things the right way, build things with transparency. Some of these toolkits will be around like developer tools, right? Like, for example, ensuring that you have the safety information for every LLM that people want to use, like pre-publish with it, so they make intelligent decisions about what they're picking, and are they going to fail a safety test later? Like, you can try to inform people through developer tools. And then there's always like runtime mitigations as well. I think Joaquin, you mentioned like, you need to have many layers here because one layer may fail, one layer may need to be skipped because of, just the pressure to launch or other constraints. And so having that toolkit really helps you meet like the product team in the middle, so that everyone is reasonably happy. Oh.
So you're saying no full body contact, sports, and fights will lead. Okay, got it. Okay. So coming more to solutioning side, going beyond the challenges, what are at the top level some of the critical investments that a business can make to get ahead of this problem, especially as the shape and size and the texture of the problem is shifting? Like, what are the fundamental investments a company should make? Maybe I'll start with Hema here.
So I like what Grace said, right? Like you can have tooling and automation because you don't want to stymie innovation. You want to give developers that ability to experiment, to try, but then how do you create code scans? How do you create, some kind of automated security questionnaire? How do you create observability tools just to know what bits are going across the wire and quickly take down a system that may be going rogue, right? I think there's a lot we can do, and it doesn't have to be long drawn, processes. And I'm actually excited for, AI helping to make some of that automation happen.
Yeah, I'd say maybe three types of investments, and I'm gonna mention the one you just alluded to last. The first one is data science. You need metrics. It's extremely important. Metrics are always imperfect, but they're always useful, almost always useful. And they force you to think about the problem, right? And they force you to debate. So then the second thing is you need to be able to compute those metrics at scale, and you need to empower other people, right? Not only the centralized. I'm always a little bit skeptical about having a centralized team that's responsible, for responsible AI. That in the long run, that doesn't work, right? It has to be everybody's problem. And so you need a platform. So you need data science, and you need to have a very, very strong internal platform, the right data tools and so on, so that everybody can compute the metrics, right? And then the third one, like Hema is saying, we're seeing amazing progress in being able to use AI for AI safety. Sometimes I think about it as like fight fire with fire, somehow, where you can actually throw a bunch of tables of recent activity at some of our most advanced models at OpenAI, and you can ask them, go look for suspicious activity. You don't tell them anything else. And they'll come back and they'll go like, well, you know what? I've been looking at like patterns of access, let's say on the ChatGPT interface, or like on the API, the patterns are different, of course, right? And they're like, and here's what I've learned about like, I don't know, just like number of tokens, in or egress in general. And I've seen like these, I've learned that certain locations and certain IPs here look very strange. You should look into that. And that's just like with zero specific training. So I think doing some of the work that Hema is doing at Kumo, and then where models are going, and especially with reasoning, I see a world where humans still need to be in the loop, but AI can really help us scale. And for that, you need, of course, humans need to decide on the metrics, right? So that's essential. And I mean, you can use AI for coding as well to build a platform, right? But we still need to have a good platform. But then again, yeah, have AI on top, help us do the job.
I think I'll just add one thing that we didn't really talk about is like defining standards. Like what exactly are we enforcing? Like what is a pass or what looks good? Like one thing I've found super helpful is just as all these products are being built, like getting engaged with all of them, testing a product, understanding what they do, and then start to categorize them. There's a lot of different ways you use LLMs. Some are generating output, some are not generating output, some are generating standardized outputs. Like, how do you think about all these products? How do you give them categorizations? And then how do you define, like, what are the standards for each? Because different risks don't apply to different types of products. I found that super helpful to just like clarify the landscape. Otherwise, like, you're dealing with dozens of products and you really can't make rhyme or reason of them. And then having those standards makes it very easy, relatively, to roll out, because then everyone understands there's this consistent bar for every single product and no one's like getting more or less than any other product.
Thank you, Grace. I'll add one more thing to everything you guys said is we focused more on actually infrastructure. This is the time to not have a centralized responsibility, but to actually empower, enable, educate every developer. So this is, I like this shift left phrase. So I'm hoping that using infrastructure, we can shift left. We can inform people early in their development cycle. We can make responsible AI a part of the design instead of something at the very end that we may need to gate. So educate, empower, enable with infra. Okay. One question, given the landscape of even the types of concerns, principles that we may have to worry about changes so fast. One is, I'd love to hear any one of you speak to pre-generative AI, post-generative AI, how has the responsible AI landscape shifted for you? And second is, along those lines, how do we be prepared for the future? Like, how do we keep up with what new kind of attack surface, what new kind of principle, what new risk we have to worry about? And as the head of preparedness, maybe it's the right question to start with you, Joaquin.
I remember when I started to pay attention a little bit to what I guess like Gen AI, deep learning, like the powerful massive LLMs and so on were capable of, coming from a world where I started to work on machine learning in, I think, 95 or something like this, you know, training tiny models by hand, writing the actual math for the learning updates and so on by hand, right? To a world now where I would read in the news, you know, oh, you know, so-and-so, maybe Dario Amodei or maybe, you know, Sam Altman or others are warning that these models can maybe develop their own objectives and become misaligned and so on. And initially I was like, yeah, sure. I mean, that sounds like I don't buy it, right? And then when you really get hands-on, and especially now that we have models that can reason and you can actually inspect the chains of thoughts, you start to see behaviors that we call deceptive alignment and reward hacking, you know, where the way I would describe it, I haven't seen any sign of malice. What I have seen is what a mischievous child might do, right? Like if you give your mischievous child an objective, it's just going to try to cut corners, right? It's just going to, and it wants to please you very bad, right? But it's just going to, you know, it's kind of like going to cheat right at the test if it can, right? And not out of malice, but just because, you know, that's just the stage these models are at. Obviously, if you now put such a model in control of critical infrastructure, then you have to start to be a little bit careful, right? Like you probably wouldn't put a mischievous child in control of critical infrastructure. As far as future proofing is concerned, I honestly just go back to what I was saying earlier about like taking these practical and calibrated approach, iterative deployment. We're advancing the science, of course, of understanding misalignment. And then again, like we call it, this term kind of surprised me at first, the Swiss cheese approach. You know, initially I was like, what does that mean? And apparently, like if you cut slices of Swiss cheese, they have to be uncorrelated slices, right? Like the holes will be in different places, and if you stack them up, then hopefully you have no holes, right? So what can you do? Apparently, people in biology talk about that approach, or in biosecurity. Yeah, you absolutely need to have like a very practical approach. And the last thing that I cannot emphasize enough is what Grace was talking about earlier as well, which is like, this has to be everyone's problem, right? Like in any company that scales, You don't have like one team that's focused, they own privacy and no one else works on privacy. It's like, no, everybody understands the importance of privacy, right? The same thing has to be true with the other concerns.
Hema, this is a question for you. As always a champion of this, what role does diversity play in building good AI solutions? And I would challenge you to think about diversity in multiple dimensions, be it demographics, be it functions, because we're in a world where so many different domains are merging together. So I'd love to hear from you on it.
So thanks, Sakshi, for asking me that question, because I think I've always been an advocate that teams are a composite of all of the brains, all of the neurons that, compose that team, right? So we all come with our individual blind spots, and teams complement to each other. So I don't necessarily think so. I think of axes like, gender and demographics as just ways maybe the hiring team can, create a diverse funnel. But I really think it's up to a manager to know how, people are different and what perspectives they're bringing to the table. Like, you may have a really strong engineer and you may have someone who's really creative. How do you bring them together? And I think if I think in terms of LinkedIn vocabulary, which is, the leadership, execution, craftsmanship, not everyone's going to always ace all dimensions, but how do you make people with different of these different characteristics work together, right? And I think it just makes for more delightful products. And yeah, right.
Yeah. I don't know how we're doing on time, but this is such an important topic. I'm gonna push this to the extreme and say that I don't think you can actually have a robust approach to responsible AI without diversity and inclusion, period. It's a little bit like the Swiss cheese of cognition, right? To what you're saying, right? I have holes in my Swiss cheese. And right now, I say this being very sleep deprived this week as we're working on the preparedness framework version 2. And I can tell you I spent countless hours disagreeing in robust discussions that were so exhausting, where I'm like, oh my God, I'm so tired of this person who thinks, differently and who's poking holes here and there. But what I can tell you is it's, I guess, Wednesday today? No, Thursday? I don't even know. But whatever day it might be. And I know that compared to where we were Monday, the draft is so much better, precisely because you have that tension, right? So that tension in a healthy way, in an inclusive and diverse way, creates robustness.
And one last question, I'll open up the mic to whoever wants to take this, is we have lots of, or all of folks here are professionals engaged in workforce and in an era where the, work is changing its shape a lot. So just like we spoke about how to use AI to do AI responsibly, fire with fire, I'm curious what any advice that you have for professionals in this room on how they can ride this wave of this new AI era. Grace, do you want to kick us off?
I mentioned earlier, AI is a tool. You got to know your tool ins and outs. And I don't necessarily mean getting into all the math, but you do need to know what it can do and what it can't do, including, and the can't do isn't just like, oh, it can't do math, for example, in some cases, right? But the can't do also on the responsible AI aspect, right? Where it doesn't know that there's bias in it. And so you have to be the one looking out for it. So yeah, knowing how it works, that I feel like that's always wise.
I think advice I always give young professionals is work on a problem or a product you really feel passionate about. I often find people chase titles, compensation, whatever, like other metrics. And I feel like when you actually love the product you're building, you'll do it the right way and you'll build something amazing. So I think that even from a responsible AI perspective, you'll think about it from every single angle as opposed to chasing some other metric, which doesn't really matter.
I would say two things. One, play the long game. Play the very, very long game. Don't optimize in the short term. And the second one is get uncomfortable. And as you work on AI, make AI yours. And what I mean by make AI yours is like find your way. AI is going to be so general in what it can do. To your point, am I right? Like find your passion, make AI yours.
Okay. With that, we'd love to open this up for any questions from the audience. I think we have time for one question. Make it count.
Hello. Hi, everyone. Thank you so much for the wonderful panel discussion. My name is Krupa, and I'm a security data scientist at Visa. My question to you is, as AI systems become more complex, failures are inevitable. What kind of future accountability mechanisms should exist when AI systems cause harm, and who should be held responsible?
Anyone?
I'll say a few words. I mean, I'm not sure about who would be held responsible per se, but like there's a reason I didn't study law and things like that. But I think what King you mentioned earlier, human in the loop, right? So I think that changes a lot of the landscape versus just having like agents just doing completely taking actions without anyone in the loop. So I think that if we were to build in a way where humans are often in the loop, that may clarify up the accountability aspect, but I think that also diminishes the risk a lot.
Yeah, I think to Grace's point, that's the journey we learned at Kumo as well, like giving the user controls and knobs. Because when I would sit down and work through the legal aspect of DPAs and all of the legal paperwork that I was having with security and legal teams, I realized that as a platform, just giving user control was what mattered the most, and the ability to inspect, what data went in, what is the model doing, then as opposed to having black box systems.
I think there's going to be a lot of work still for humans to figure out the legal frameworks. If you're driving your car faster than you should, right, illegally, and you brake hard to avoid an obstacle and the brakes fail, and you hit the obstacle, then you're like, okay, well, was it the fault of the car manufacturer because the brakes shouldn't have failed, or was it your fault? Is it going too fast, right? And now think about that in the context of AI. Is it going to be us building core models? Is it going to be teams building platforms? Is it going to be people building the product and using? You're going to have the whole stack. So we're in for a really exciting time.
I think let's thank all the panelists for sharing decades of experience and wisdom with us. Thank you.
Thank you. Thank you. Thank you so much. You could leave that here. Okay, we are ready to switch gears. We have two exciting lightning talks lined up. This part will address the at scale portion of the title of this meetup. The first up is infrastructure for serving LLMs. And I'd ask that maybe we can wait for the Q&A until after both the talks are done, just because we're running a little behind on time. So yeah, first up is Ying Zhao and Tiffany. Ying Zhao is a software engineer at LinkedIn, and she evolved from UI to backend development. Now she's part of AI platform engineering. She was inspired by Grace Hopper, and she actively engages in women in tech events. Thank you. She believes in the power of diversity to drive innovation. Outside of work, she enjoys snowboarding and outdoor adventures, embracing the challenges both in AI and on the slopes. And Tiffany is a software engineer at LinkedIn, focused on AI infrastructure and democratizing LLMs across the company. She's currently designing and integrating benchmarking framework to optimize LLM interface performance. Her ideal mornings include coffee, yoga, and a game of Queens on LinkedIn Games. So plug for all of you to try out LinkedIn Games. Okay, over to you.
Hey everyone, thanks for joining us. So today we are going to talk about infrastructure for serving LLMs. My name is Ying Jiao and this is my partner Tiffany. So here's the agenda of our presentation. So firstly, we will give some introduction on some basic context on what is LLM serving. And next, we are going to talk about LLM serving our team in LinkedIn. And finally, we're going to use a production use case to help you guys to have a better understanding. So firstly, what is LLM serving? So serving is the process of deploying and running large language models to generate real-time response efficiently. It ensures low latency, scalable, and cost-effective inference for applications like search and code generation. So let's take a look at this diagram to help us to understand serving. So this is what is happening under the serving. So generally, it has two phases. One is prefill, one is decode. So serving is basically help the users to interact with LLM. See this example, the user is asking LLM a question. Is apple a fruit? So in the first phase, we called prefill. We dump all the input tokens to LLM at one time. And next is the decode phase. Based on the input tokens, the transformer in LLM will process all the tokens and try to generate a response and get back to user. In the decode phase, the tokens are generated once a time. So see this diagram on the right side, it generates yes, and then it, and is. The next token is generated based on the previously generated tokens. That's why usually decode phase is usually taking more time than prefill phase. So this is what happening under the hood of serving. Later, Tiffany will talk about the serving infrastructure. So why serving is very challenging for us? Because it needs high latency. As I mentioned in the decode phase, LLM generates tokens sequentially, making real-time response very slow. Secondly, it needs huge memory. For example, imagine if you want to serve 70 billion models, it needs 4 A100s. As we all know, GPU are very expensive, so which bring us very high cost for serving. So these are the challenges for us. Our team, as AI infrastructure in LinkedIn, we aim to build a scalable AI serving stacks for LLM inference at LinkedIn. We have 3 key focus areas: high throughput, low latency, and high availability. So next, I'm going to hand over to Tiffany to talk about the serving infrastructure in our team.
So our team is responsible for serving models both externally and internally. So what this means is that we're hosting these models. Our users can interact with our platform through either a direct API call or use a LangChain SDK to interact with our API interfaces. We incorporate the open AI standard APIs such as chat completion, completions, and embeddings. On top of that, we actually work with our AI engineers to customize interfaces that support specific prompts for performance gains. So for our externally hosted models, we have a mid-tier service that will orchestrate inference calls to Azure. And for our internally hosted models, we allow our customers to use various open source inference engines, and we customize how we start these engines based on the product's use case. On this layer, we also introduce load balancing and rate limiting. We need rate limiting because to solve for the high compute costs, we actually have clients share models because not every client actually needs all four A100s to generate their inference work. So when we talk about optimization, we really talk about throughput and latency. Latency is particularly a pain point for LM inference. As Injal mentioned, the decode phase is computationally heavy, and by nature, that means high latency. And on top of throughput and latency, we also care about GPU utilization. Like Injal mentioned, GPUs are expensive, but not only they're expensive to buy, they're also expensive to operate and to power. And that's how we our work relate to responsible AI, because we should make sure that like we're efficiently using our power to power these AI. Our optimization strategy is highly use case dependent. For example, a chatbot might be more concerned about low latency so it can maintain conversational flow, but a batch processing process might just only care about throughput. And that's why we have to customize how we start our engines. Traditional metrics like total request time and requests per second doesn't really capture enough, isn't granular enough to capture the inference metrics. So we actually use a different unit of measurement known as tokens. Tokens represent about 4 characters in the English text. So we use tokens per second to represent throughput, time between tokens, time to first tokens for latency. And on top of that, we actually monitor our token cache rate. So in the inference engine, there's actually, during the pre-fill phase, we can cache, have the model reuse some of its computation and therefore reducing our latency. So I'm going to show you guys some real life data to see what kind of latency we're looking at. So on our x-axis here, we have our utilization rate, and on our y-axis here, we have our latency. So that is, latency here is actually in seconds. So can any one of you guys imagine waiting up to 20 to 30 seconds before your application to respond? And we live in a world where the instant response is the norm. So this is how we start solving the problem by using streaming APIs. So we actually do tokens per time between tokens. So this, what this workflow is about 40 milliseconds per token, and that equates out to about 25 tokens per second. Which is actually acceptable because the average human can only read up to 5 to 10 tokens per second. So now I have a trivia question for you guys. What latency metrics will we prioritize for in the chatbot? Yeah. Sorry. How about back there?
D. Time between tokens.
Do we have one more guess out there? One more guess? It's actually time between tokens. Yeah. And this is because when you interact with a chatbot, you're kind of reading it as the tokens are outputting one by one.
Okay, thanks, Tiffany, for talking about infrastructure for serving. Next, I'm gonna use a production use case to help you guys understand more on it. So I'm gonna use linking Hero Agent this project. So this project give you some context on this project. This project we wanna build some agents to help recruiters to do some hiring process. For example, recruiters can give the AI agent some comments, such as, I want to hire a software engineer who has 5 years of experience and who is familiar with Java, and the location is Bay Area. And the AI agents, instead of it is a LLM. The LLM will process the commands and to do some executions. For example, the agents can find the qualified candidates and send them some emails and scheduling interviews for the recruiters. So our team's responsibility for this project is to serve the LLM inside the AI agent. So once we get this project, what we do is we analyze the challenges and analyze the key metrics. So the challenge in this project is it has high GPU requirement, but we only have limited GPU to support it. The second challenge is high token count. We have 5K input tokens and 900 output tokens. As you can see, it can create heavy prefill and decode workloads. After we evaluate the challenges, then we realize 3 key metrics we need to focus on for this project. The first one is time between tokens. We want to make it as lower as possible, as Tiffany already showed it in the picture. Several seconds ago. And the second metric is we want to try to reduce the GPU utilization. As we mentioned, it's very expensive. The third thing is we want to make the total request time okay. We don't want to make it too high. And after we do all the analysis, we will come up a resolution. So in this project, our resolution is to adopt an inference engine called VLM. The reason is that it can provide 10% GPU numbers reduction compared to other inference engine, for example, SGLang. After we choose this inference engine, we also did one optimization is we enable the prefix caching in VLM as the input prompts to the AI agents. 50% of that are shared prefix. By enable the prefix caching, it can help us to optimize it. And we even update the VLM version to V0.07 to give us a higher throughput. So this is a production use case. And finally, we are about to end this presentation. So let's go through what we have talked about today. LLM serving is expensive, but can be optimized. Latency and memory are the biggest challenges in serving area. At last, we can use techniques such as prefix caching, speculative decoding, flash attention to help us scale efficiently for serving. Okay, that's all about our presentation. Do you have any questions? Okay.
Yeah, we will hold the Q&A until the next talk. Thank you, Tiffany. Thank you, Ying Zhao. Okay, our next presenter is Shuing. And Shuing is a staff engineer in the LinkedIn's AI platform. She leads the Graph Neural Network training platform and scaling AI workloads on Flight and OpenConnect. She's previously spearheaded LinkedIn Kubernetes strategy for online services, and now she partners on the multi-region global scheduler for training workloads. She has a PhD in computer science, and she specializes in distributed systems, AI infrastructure, and program analysis.
Thank you, Swati. All right. Yeah, so we're going to talk about graph neural network training platform at LinkedIn. And I'm going to start with what is the graph neural network and what is the use cases. And then we'll highlight some of the challenges and how we solve these challenges. And last but not least, what's the impact we have so far. Right. So as a dark matter of the AI world, 80% of the data are unstructured. And as we show here, the LinkedIn structure are inherently as a graph, right? And so this graph neural network, short for GNN, it can learn the lower level dimensions of the embeddings for the nodes, and it captures relationships across the domains, right? And so we can use the GNN at LinkedIn to predict the unseen properties of the nodes and unseen relationships, right? And so how did we do this, figure out what is the properties of the nodes, right? This graph sage architecture that Hema just presented last time, just very earlier, is exactly what we use so far. And there's just 3 steps where the vertical teams will formulate their data into a graph, right? And then we collect, sample the nodes by 1 hop or 2 hops, right? When we get the nodes, the second step is to aggregate features from those nodes. And then we are using those graph contexts and labels, and then we can predict the unseen features or the relationships. Right, and so seems like theoretically it's very simple, but in reality, the complexity comes threefold. The first one is the scale of the graph and the data. And then the other aspects is a secondary one that, as we explained, first one, the graph and the data size, it actually determines what is the system architectures we'll be using to do the GNN training or including inference actually. And so the graph data size, say, if it is small enough, it can fit in a single machine, then we can use the local data, and then you leverage the NVLinks, and then we have the very efficient memory access between this data graphs and the training. But if your graph and the data is really big, you have to partition this graph and the data to multiple nodes, and then maybe in the CPU nodes but your training is on the GPU nodes. And so you need to deal with the cross-network RPC called cost, and also in some cases we have the infinite band enabled, and then to access the faster memory access remotely across the nodes, right? So these are the causes complications across the stack from the top to bottom. And then secondary of the challenges comes from the number of hops and the number of neighbors. So this is during while training, we'll query some graph engine for the data, for the nodes and the features, right? And then in each of them, we cannot afford to get all of the neighbors or go fan out to as many of the nodes as we can. Although we can have enriched information about that, but we cannot do that. And so this will cause this overload across the network during each training loop. So on the right-hand side is we just show some of the scales from different vertical teams where they formulate the graph and the data and the nodes and the edges and then the graph size, right? This is some numbers as of from last quarter before the MMEs. And so here, as we talk about the challenges and the complexities, and then right now, what we are actually have these systems look like just from 10,000 feet view is that, as we say, the AS or TMS or all the vertical teams, they will have to formulate their data and output this graph with the features. And then that will be stored in the HDFS. And then there's one critical component where we are currently dealing with is also unique from the other training platforms. The training platform is the graph engine, where we're going to read this graph and the data from the HDFS, load into memory, and then during while training is running simultaneously with the training processes, which is on the right-hand side, the last box, where the trainers will query the graph engine during the training and then move that data to the GPUs for the training. And the output of the training is embeddings. So this embeddings, as we mentioned, this captures the signals across the vertical teams, the domain knowledges, right? And then this embeddings will be output to the HDFS and then will be further used for the downstream application model training. right? And so here, there's a little bit of zoom in the version of what I just talked about, because we really we need to speed up a little bit more. But the point is on the left hand side of the box is where we run this graph engine, where it's basically a provide a graph algorithm to walk the graph and then get the two hops and samples, and then have the features aggregated. This all happens in the CPU nodes. Right, on the right-hand side is in the GPU nodes, where we're running the training processes, where when we get the batch of the data, and then we move to the, not we moved, but the data will be transferred in that GPU nodes to the multi-GPU nodes, GPUs cores, right? And then we'll go through the training, right? And so for the GPU nodes, for the multi-node GPU training, they're like very good support in the community, like a Kubeflow, MPI job, PyTorch, they're all kind of the things that we can use. But for the data, graph data service provisioning, running simultaneously with the training or inference, that is not, there's no out of the box solutions for us. And so that's where we have created a data service for the graph, the GNN. And so this is like to use to load and transform and cache the graph data. And it's actually okay, yeah, it's actually used by the other use cases for this one. We also, because the LinkedIn, the training platforms are all based on the flight, OS is a flight. And so we create a solution on the flight, leveraging the open source solution. And so here we just show you don't need to read per se, but this is what's happening from the top to the bottom. But we zoom in a little bit is that on the top part, the graph engine where it runs hosts the graph data to enable you to get the graph, one hop or two hop neighbors nodes, right? And then there's a feature store where you query the features and then on the middle part is the sampler and with the queuing, but we are not going to touch the details in here. But how these two layers interact with each other, which is the open source solution we have created in the flight. So here we're just showing how this multi-nodes distributed graph GNN training and infrastructure look like, which is empowering the training and the inference for across the AI products at LinkedIn. And then on the leftmost side is a user space where they specify how I'm going to run the training. And also, if they're, as we mentioned, if their graph and the data is big enough, it's have to partition across the nodes, and then they specify how they want to run this data service task. And then in the middle layers, where the supply of our new solutions will provision this data graph service. And and also there's some plugins to hook with the open source MPI job for multi-node trainings and stuff that is existing, right? The green box is the new solution that we enabled. And then on the rightmost hand side is the low-level Kubernetes compute infra side, where the graph engine is a spin-off and is have a static endpoints where we allow this training processes running on the training clusters to access and and do the training. And so so that platform have a bunch of applications where I just highlighted some oval boxes here, including this top applicant jobs and then job you might be interested and people you may know and the ads and stuff. But here, a quick trivia question. This is $1 billion impact of GNN so far, and what you guess, like which major industry has been the largest financial gain from the GNN adoption? Let's try again. Go ahead. Try again. Where we are? Where are we? What are we? LinkedIn. 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 Right. Anyone guess A? Yeah, so the the answer is e-commerce and recommendations have the largest financial gain from GNNs, like the Amazon, Meta, TikTok, Pinterest, Snapchat. You know, a long list of the companies, the large companies with larger scale, which use GNNs to boost their business metrics. Yeah, so at LinkedIn, what is the business metric we have so far, right? So from the last July, there's a major member experience like MME, the models from ads, from the recruiters, from the premium, just are reported from our vertical teams. So they're using the AI platform where they use the genuine signals, the cross signals to get their business metrics boosted. Yeah, so this is a very collaboration across companies as well. So the DeepGNN part of the graph engine, and so that's we use the Microsoft DeepGNN and then OSSO Flight, where the orchestration platform where we have the open source solutions to them, and also the NVIDIA to enable like fast, scalable gen training. Cool. So I'll hand over to.
Thank you, Shuing. We probably have time for one or two Q&A. However, we could even go to the networking section where folks can ask more questions because I see a lot of weary faces. Maybe you want some refreshments. Okay, please, a big round of applause for our lightning talk speakers. And I also wanted to call out the core team, without which this event would not have been possible. You all know who you are. I see all of you like spread out in the room. Thank you so much. And this includes women in tech groups at LinkedIn. We have volunteers within the LinkedIn engineering organization, and working with women in big data, and our event management team. I think Nancy is here somewhere, and Renee. Thank you, everyone. It takes a village. And before we go, we also wanted to plug for women in big data. Please scan the QR code. You can join us, be a mentor, and volunteer. That's the QR code. We'll have some of these QR codes playing in a loop during the networking portion. And last but not least, we are hiring. And I'll put this QR code also out there. Oh, actually, in fact, this is the last part. We would really value your feedback. While this is fresh on your mind, please scan this QR code, and there's literally 3 questions between now and the refreshments. So please, if you could take just a minute to provide the feedback, then I'll keep the QR code for LinkedIn hiring open, and then we're open for networking, more Q&A, headshots, and rock your profile. We have volunteers at the high tables who can work with you if you would like to rock your LinkedIn profile. Thank you, everyone. Oh, yes. Share.
All right.
Okay, that was long. That felt much longer than it was. Right?
Sorry, we ended up having some mic issue down.